Okay, hello. So I've prepared a little bit, not too much. By the way, I have a different setup today. I don't feel that good. Also, I have a new computer, work computer, which is hooked up to my office. I'm not sure about streaming from that. Anyways, uh, I've been playing around with this concept, and what I thought would be fun is if we can try to build the like very simple app, but we're gonna do it in two different ways. So on the top here, I have this like framework thing that I'm just playing around with, uh, and then we have just a plain project. And the point is that if oh, I stream it. Huh? Det går bra. Sorry, it was just our daughter came home. Let's see. Okay, so what we're gonna do is I'm just gonna start developing this, and then we're gonna see how they differ. So on one side here, I'm just gonna say, please make demo. Please make it a simple counter app. And then I'm gonna say the same here. And what's the difference here is that you can imagine this as like an actual npm install of like a state management library, but it includes agent skills and actually an MCP server. And that does some interesting things. So, okay, so we have the first one's done. So we have a simple counter app here, and let's look at the code. And in this code, we see that it just goes ahead and basically just implements the counter as we would expect. Maybe I should make it a bit bigger. No surprises there, but let's take a look at what happens on the other one. And that's going to take some more time because it's going to actually consider the architecture of the app. So it's basically setting up the base architecture of that app. And we're going to talk more about what that architecture is. But let's see. So let's look at the other one. We still have a counter. It didn't have the nice colors, but whatever. But you can see it did it differently. So instead of importing state, it imported like use app. And on that app, it pointed to, do we have, let's see, restart TS server. Why don't we have any IntelliSense here? Where's my IntelliSense? Ah, that sucks. Count. Well, it's a number. I'm not sure what happened to my intel. Maybe I have to open the file again. That's super weird. App state. Anyways, it's a number. I'm not sure what happened to the IntelliSense. And then we have the actual state is in a state file. And it just uses a concept of atoms. And this is not, like if I were to design state management for a human, that would be very different, right? But here it's just called an atom, and it's just being exported from this state file. And this state file is going to grow like crazy. And that doesn't really matter for an agent as opposed to a human. And then we have effects here, but we don't have any effects yet. And then we have actions. So in actions, we just export like functions. And these functions, they have a context of state, actions, and effects. So this is where it writes all its logic. It kind of sucks that I don't have the IntelliSense. It's super weird. Anyways, and this is all typed as well. And then in our main file, this is where it wires it up, and then it connects the DevTools. So what's gonna be interesting here now is, let's see if this is actually running. Yeah, cool. So I can say things like, what is the state of the app? And I think this isn't super obvious to people. And the thing is, yeah, so you can see here, it actually looked at the state of the app. And then I can say, please increment it. And what we're basically doing here is that we're hooking into the actual app and its state. And when you think about agents and debugging code and understanding code, and especially debugging, one thing is like looking at the static code and figuring out what's wrong. The counter is now at 2. It is at 2. I think I also have, yeah, we can look at that later. My point is, when agents work with code, they just look at static code. And a lot of bugs can be inferred from looking at code. But a lot of bugs cannot be inferred by that, because it's the state that the code generates, right? You can kind of predict it sometimes, like looking at the code, but it's really, really difficult. So my theory here is that if your agent is actually able to interact with the state of your application, look at the state of your application, look at the history of changes, like all the actions, what state changed, what effects were called, everything like that, it's going to be much, much better at working with your app. That's it. That's kind of the demo. But I thought we could try to move on a little bit. Make this a simple to-do app instead. So we're also going to take a look at how it actually builds up the components and everything. Yeah. Make this app instead. So let's see what the other one did. So it just added some more state here in the same component. It added add to do. Yeah, basically used set state and still working within the same component file. Now, and this is the thing, is like, when I talked about like having state and actions and effects in like single files, is that for an agent, it's far less to look at, right? You can imagine you having like hundreds of components, and then you're trying to tell it to like figure something out. And all the state is like split into many different components, and it's like really, really hard for the agent to figure out, or it has to build up a lot of context to figure out where things are. But when you have something as strict as this, where you just have like state, effects, and actions, and it knows that architecture, that's the only place it needs to look. And it knows how everything looks like. So it should be much faster to go and figure out things. So let's see now. It's changed some things. So which one is this? Oh, this is framework. Okay, so now we have the to-dos. We have new to-do title, and it's extended this stuff. And we have like the actions as normal, like nothing special here really. Just has the to-dos. One thing I'm a little bit, I haven't actually tested this, so One thing that surprised me a little bit is that it didn't use it. There is like another skill here called UI, which it didn't trigger for some reason. That's kind of weird. But yeah, whatever. That's not the important part. There's a UI skill here as well, which makes sure that you have UI components, which are like isolated components doing styling, and it can have internal React state. But then your main application, or let me just do it. Please use the UI skill to refactor this. Yeah, I'm actually curious how skills are loaded. I haven't actually researched that. Like, when does it decide? But yeah, I'm just going to ask it to use that skill, and then we're going to take a look at the code. So you can see that it splits it up into multiple components, and as I said, these components, they are not necessarily stateless, but they are the components that contains the styling, and they can have internal state. But if we look at the app, like the main components, they never do styling, and they don't have internal state. They always use the app state, right? So you have this very clear separation of concern where you have your application state globally used through like the application components. But the application components, they only compose UI components where they pass like the state down to them, and then hook actions to change handlers like this. And then you have the actual UI components, which has the styling and any like internal component state. Okay, cool. So let's try something else. Please create an async JSON storage. Just using please create an async JSON storage just using local storage with some fake delays. Let me just copy that. Oh, for fuck's sake. Please create an async JSON storage. What did I say? Just using local storage with some fake delays. Okay, let's see what happened in the other one. So here, oh, this is interesting. What the fudge? Even here it created a JavaScript file. That's interesting. Why did it do that? Huh. Anyways, so it just added this storage, and it just uses this storage, I guess. Oh, I didn't actually tell it to make it load the to-dos from the storage, and also update the storage whenever the to-dos. Whenever new to-dos are added or changed. Yeah, and you can see here it's actually doing testing. It's kind of cool. So it makes changes, and then it uses the MCP server to go and actually verify that things work in the live application. So we should see, did it actually add something here? Yeah, buy milk. It just added that by itself, which is kind of cool, right? What? Oh, I think maybe these are old. So I'm not going to say that it did something wrong. It's just because it's old, like from the previous demo. Cool. So that's working. Let's look at code for it. For some reason, it wrote JavaScript for this one. But then in app.jsx, you start to see what happens, right? When you just go in and you just start coding with agents, they just use React, right? Of course, if you had Redux or something like that, probably it would use that instead. Yeah, I'm actually unsure. Maybe Redux would be something it did relatively well, but even Redux doesn't have like, I guess if you, of course, you could just add a Redux skill. Like it's not the framework that does this, it's just the skill. But I think it says something about the importance of having a skill that describes the architecture of the app. Anyways, so now it has added like, but what I mean now is that it doesn't have like strong guidelines on how to manage async stuff, for example. So it just adds like a loading state, a use effect, and all of this stuff. And then update to-dos. Yeah, it just updates the to-dos. So the other one, let's see what the other one did. So the other one doesn't seem to have changed anything on the actual app. But what you can see here is that it now used async atom for the to-dos. So basically what it expects to do, let's see if we can find it here. Yeah, so it added like an initialize action, and I guess it runs that immediately. Yeah, when the app runs. And in that initialize, it loads up the initial to-dos. And that's a bit of an ugly... Okay. Anyways, it loads up the initial to-dos, and then whenever it wants to update those to-dos, it does it optimistically. It's still able to update the to-dos. So even though it loads it asynchronously, it can still update the to-dos normally with an async atom. And then toggle, it just toggles it optimistically and saves it, and so on and so on. But again, it went in and actually tested it, which was really cool. So if we load it again, it works. That's nice. So what if we ask it to please add a filter? Well, what we're actually going to do, I want the to-do to be a bit faded when it is added and toggle while it's async updating. See if I can copy it now. Yeah, let's do the same here. Yeah, so I guess like my main message here is like how important it is to have a description of the architecture. Like how do you want to do async stuff? How do you want to organize your code? How do you want to organize components? Where should stateful components be? What are stateless components? All of this stuff. But then also like, okay, maybe the main message here is more like the actual the coolness of an agent actually being able to interact with the state of your application. As you could see here, it can help debug, it can help it test things, if you interact with the app and you get to a bad state, you can just go to the agent and say, hey, I got to a bad state. It's able to go in and look at everything you did that got you into that bad state. Okay, so what does it do now? Pending to do IDs, tracks ID is currently saving. Yeah, so it chose to add, yeah, low. Cool. That's pretty nice, I guess. Efficient way of handling it. By the way, if you also see here in the log on the right, it's kind of tiny, I guess. You see that when we initialize, you can see it called effects get to dos. Oh, the promise. We should really have that not being the actual promise. Anyways, and then state to dos. Oh, interesting. Pending to loading. Oh, yeah, I haven't really written out the async atom stuff. Anyways, so when we toggle it to do, we see what to do. We toggle, we see that it updates the thing. It updates pending to do IDs. Yeah, we have storage, effect storage to do's. Anyways, so you have all the information about what is actually executing. And then let's take a look at what the other one did. Yeah, I guess it basically did the same. Oh, it added a set. That's interesting. That's also weird. Like, why didn't it use an object? Will this actually work? That's kind of weird. That technically that doesn't really work. Like set pending. Oh, it actually creates a new set. Oh, okay. Interesting. Yeah, I thought it would actually like just use the set. But yeah, I guess it's just to prevent any duplicates. But it's a weird thing to do. Use a set with a use state. Anyways, so yeah, I guess that's kind of what I wanted to show. I haven't really tested this like in terms of scaling. I need a project for that first. But yeah, it's kind of cool though. Like I can even go add 5 more five more to-dos to the list in the app. So it's actually doing it using the actual functionality of the app, which is kind of cool. And you can see it's adding it here while it's working. Call mom. So this is also another thing. Another part of this is that if you think about things like browser interaction for testing, it's incredibly expensive, right? Because the agent has to like actually look at the screen and then like move the mouse, click the mouse, look at the screen again. It's like, it's very, very expensive type of testing. But in this case, you can rather just call the actual function or the actions and change the state and everything. And then you can take a picture of it after you produce the state. Yeah. Again, I think there's just something that tells me there's a lot of potential with this. Cool. Yeah, I guess that's it. That's what I wanted to show. So I guess bye for now. Bye bye.